Okay, so you know there are addresses involved in crypto. So of course we also have to have our own type just for an address. The msg.sender from the previous chapter is actually exactly that, an address type. So let's take a deeper look at what this is. The address type is 20 bytes long. So if you're storing it in the Ethereum virtual machine, remember there are 32 byte slots. So you're actually wasting 12 bytes, but that's usually okay. But if you want to really optimize it to the last bit, you can try to remember this for the future. The address type also has a few extra features. You can have a normal address type or a payable address type. They are basically the same, but the payable is meant to be able to receive Ether. So if you plan on sending Ether to such an address, store it as payable. And you can always just easily convert between the two types simply by using the address or payable keyword, as you can see here. You can call balance on it to read its current Ether balance, which is in the Y unit, of course. You can call transfer on it, like we did in our first example, but keep in mind this is not encouraged. Instead, it's better to use call, which is the third option. And also note that I left out a few more low-level complicated aspects of the address type that you usually don't need. Let's take a look at the difference between sending Ether via transfer versus sending it via call. So here you can see how we would use the low-level call function of the address type. This means we are sending a transaction to it. And in curly brackets, we can define the transaction parameters, either the amount of gas or the amount of Ether as value. And in rounded brackets, the data. In this case here, we are only sending Ether, not calling any functions, so we leave the data part empty. You could add data here to call functions in a smart contract, which would need to be application binary interface ABI encoded. But usually you don't need that since Solidity has a contract type, which is like the address type, but allows you to do these kind of calls just by writing functions calls in Solidity. But just for sending Ether, this is actually the recommended way. So why not just use the transfer function? So here you can see that the transfer function is the same as using the call function, but you additionally set the gas parameter here to 2300. What that means is this call to the contract itself is now a new internal transaction that can only use 2300 gas. If it needs more, the call itself fails and the Boolean success here would be false. So why is this sending 2300 gas and what's the problem with it? The idea from transfer here was that usually you want to send Ether either to a normal address or to a contract that doesn't have much extra logic. And the gas parameter serves as an extra re-entrancy check. You can read more about this in the documentation, but the short version is that there are sometimes hacks where you call another address and then this address in return calls the same function as the one that was calling it, creating an infinite loop or re-entrancy. This can be quite dangerous sometimes, so the 2300 gas was meant as extra precaution. So why is it now discouraged to use transfer? Because there's no guarantee that Ethereum virtual machine opcode gas costs don't change in the future. And in fact, they have changed several times in the past. So it's possible that you have a contract that currently doesn't exceed 2300 gas, but in the future might do. So it's better to just leave the gas field empty. So how much gas is sent when we don't define the field? Then you just pass along all the gas that the current transaction has. But of course, there must be enough gas after this call to finish the current function call. And to protect from reentrancy instead, you can use special reentrancy guards or other mechanisms that you can read online.